Welcome to Biotosis, everybody. We are back with Unit 2 of Printing Techniques, and this unit is focused on liquid based systems, which is SLA and SGC. Now, here, what we are doing is talking about systems that use liquid photopolymers to create objects in again layer by layer fashion. The key characteristics are that they use light, UV rays, lasers to solidify material, and they're very high precision and detail oriented. Now, SLA and SGC, majorly SLA focuses on high resolution and SGC focuses on speed and industrial scale production. Okay, applications are same as we discussed earlier, which is product design, medical implants, functional prototypes, molds for mass production. Okay, moving on, let's see what is SLA. That stands for stereolithography apparatus. It was developed in 1980s. SLA was the first 3D printing process, okay, and it converts liquid photopolymer into solid objects. Now here in the diagram we can see that in a reservoir a resin sort of a material, liquid material is placed, and there is a build structure that is trying to hold it and give it structure, and laser is being uh, put on it to solidify it, right? So this is it, this is what is happening there. Now let's move on with the example of machines. So Formlabs Form 3 3D Systems Pro X 800 are the two stereolithography machines that I've seen, I've used, but we can talk about others as well. There are many more. Now, printing sizes is, if we talk about, they vary from small desktop units to large industrial machines. Okay, resolution is 25 to 100 microns, better than most of the other printing methods. And key material is rigid resin, elastic resin, compatible resin, like that. Okay. Now, SLA process is mostly working on uh, CAD models, again, like we do in other printing techniques as well. So like other printing techniques, we create a first CAD model, then we go to the slicing software for the model to be converted into thin layers. Okay, and slicing is nothing but it converts it into layers so that we have a direction. We can give directions to our models. It basically happens in the printer itself, so we don't understand what's happening there. Now their printers are like that, but earlier we had to give angles also, like in 90s to 100. So there are still printers that we have to give dimensions to for printing. So slicing softwares are helping that way, and they're also helping in the infill. Now talking about printing, uh, a, a platform is submerged in a liquid photopolymer tank, and UV laser selectively solidifies each layer. Post processing, cleaning with isopropyl alcohol, isopropyl alcohol, UV curing for final hardening, right? As we have studied in the beginning only, it use UV for photo curing. Now, working principle is nothing but based on photopolymerization, where UV light triggers a chemical reaction that hardens the resin. Okay, these resins are similar resins that we use in jewelry and all those things, right? Layer thickness is thin layers, which is as thin as 25 to 50 microns, contribute to smooth surfaces, right? Now, what are the key components of SLA? They are light sensitive liquid resins, standard, tough, flexible, dental, and medical grade also. Like we use all types of resins. Photopolymerization is a chemical process where monomers link to form solid polymers, right? Layering technology achieves high resolution by building the object in ultra thin layers. Okay. So laser and laser scanning by UV layers. So example, 405 nanometer wavelength key, the laser is being projected, with which uh, when it falls on the resin, it solidifies and makes it material. Okay, and there are also like lasers there. So if two types of lasers are cross linking, they're making shapes into the resin. making it very precise, which we cannot do with hands or any other printing type. Mirrors or galvo systems direct the laser accurately, as we discussed. SLA applications. So, medical applications are customized prosthetics and implants, dental aligners, and surgical guides, right? For engineering, functional for prototypes and small batch production, tooling for injection modeling. And in consumer products, we can be as jewelry, eyewear, and art. It can be anything and everything under the sun. And case studies can be, yeah, we can talk about case studies in the comment section. You can also tell me about the case studies, more and more case studies where we can use SLA printers. Okay, now advantages can be precision and detail, unmatched by most of the other methods. Wide variety of photopolymer materials, smooth surface finish, reduces post processing needs, right? Very less post processing is required after this, but the disadvantage is the cost, obviously, and the brittle parts unless post processing properly, right? And slow printing speed. The stereolithography printing speed is comparatively small, like slower than the other printing methods. Moving on to solid ground curing, which is SGC. And here we see that it is a rapid 3D printing method developed to overcome SLA printing's speed limitation. It uses masks to cure an entire layer simultaneously, right? So, there, what was happening, uh, substance by substance, it was happening, and the curing was being done all at once. Maybe that's why it was slow. Now, here, what they do, they cure the entire layer simultaneously. As you can see, there is some sort of difference in the structure. That is why I added the images for us to be very like we visualize the difference in the two. Okay, now model specifications are Cubital's SGC systems. Speed is faster than SLA, curing an entire layer in seconds. Resolution can be as high as 100 to 200 microns. Key features are entire layer solidification at once and automated material handling. SG, SGC process and working principles now. So CAD model is converted into mask for each layer using LCDs or DLP systems. Okay, and for curing, UV lamp solidifies the entire layer simultaneously. Material addition is excess liquid resin is removed, fresh material is spread for the next layer. Okay, and finalization mein there is post processing to remove residual material and achieve the final finish. Parallel to curing speed and efficiency, which is like more or less same, everything is same, just parallel curing speed and efficiency is there. So SGC applications are more towards electronics, which is prototypes of circuit boards and housings, automotive high volume mold manufacturing, consumer goods like packaging, custom molds, tooling. And yes, again, I will say case studies should be subject of discussion. We should discuss them in the comment section. Okay, now what are the advantages and disadvantage? Advantages is one is, as we discussed the whole time, it is extremely fast as compared to layer by layer techniques, high accuracy and large scale production. So this is majorly used in large scale productions. Okay, and reduced need for operators intervention. Okay, now disadvantages are limited material variety. You cannot change the material, like, and the material variety is not as diverse. High initial cost of maintenance and larger machines requires more space, right? Because we are doing larger production, so the machines are going to be comparatively larger than what we want to create. So those types of spaces and those machines require maintenance as well, right? So that is what is happening. Now we'll do a comparison in between the two, which is first of all speed. Obviously, we had talked about that SGC is high in speed. Accuracy is more with SLA. Material operations are wide with again SLA, and cost is very high with SGC because it is comparatively larger machines are there. And yeah, SLA also is comparatively high only. And applications are prototypes and medical, and SGC is more towards high volume molds creation. Okay. Now, in conclusion, we will talk about SLA excels in precision. SGC focuses on speed and suitable for industrial scale production. Key takeaways are choosing between SLAs and SGC depends upon the project requirement like speed, accuracy, scale, and future trends would be advanced photopolymers for durability, hybrid system combining SLA and SGC technologies. Now, these are the references, and if you have any doubts, comment below. This was a quick revision class because there is not a lot of things to be discovered in this topic, as in it was a fairly simple topic. But then if you have any doubts, you can ping me, and I thought it is good to give you quick revision notes before the exam for each unit. So that is what I'm trying to do. Until next time, thank you so much. Bye bye.